NASA's James Webb Space Telescope, JWST, has once again made a groundbreaking discovery, leaving astronomers around the world in awe. A few weeks ago, the telescope detected the earliest known galaxy in the universe, providing scientists with an incredible glimpse into the distant past. However, its latest revelation is even more astonishing: a supermassive black hole moving away from its galaxy at an extraordinary speed of 4 million miles per hour. This discovery has major implications and has sparked intense speculation among scientists and space enthusiasts about what it means for our understanding of the cosmos. The James Webb Space Telescope was launched with a primary mission of exploring the first galaxies in the universe. Over the course of its observations, it has captured stunning images of star formations and galaxies dating back hundreds of millions of years after the Big Bang. But this recent finding is particularly unusual, as black holes are typically thought of as massive entities that pull everything toward them, including light. This newly detected black hole, however, appears to be behaving in an entirely unexpected way. Instead of absorbing light, it is triggering the formation of new young stars along a vast cosmic trail. This wake of newborn stars extends an incredible 200,000 light-years, making it one of the most intriguing discoveries of recent times. Scientists are puzzled by this strange behavior, as it challenges conventional models of how black holes interact with their surroundings. A research team led by astronomy professor Peter Van Dome recently published their findings in the Astrophysical Journal Letters, further confirming the JWST observations. NASA's Hubble Space Telescope also verified the presence of the unusual black hole, suggesting that when it interacts with surrounding gas, it cools the material, leading to new star formation. This revelation is significant because it hints at a previously unknown mechanism for black hole interactions with their environment, something that could reshape existing astrophysical theories. But that's not the only major discovery made by JWST. NASA has also announced new findings related to a massive galactic merger, one of the most dazzling cosmic collisions ever recorded. This event, known as ARP 220, is the result of two spiral galaxies merging, creating a powerful burst of star formation located about 250 million light-years away in the constellation Serpens. ARP 220 is an ultraluminous infrared galaxy that shines with a power of 1 trillion suns. In comparison, our own Milky Way galaxy has a luminosity of only about 10 billion suns. This makes ARP 220 one of the brightest merging galaxies in the nearby universe. The origins of the spectacular merger trace back 700 million years, when two galaxies collided, sparking an intense formation of stars in a dense compact region about 5,000 light-years across. Within this small space, 200 massive star clusters were formed, and scientists were surprised to discover that it contains as much gas as the entire Milky Way. Earlier radio telescope studies had already identified 100 supernova remnants within just 500 light-years of this region. However, Hubble Space Telescope observations later revealed that the galactic nuclei of the parent galaxies are still 1,200 light-years apart, with each containing a rotating ring of star formation emitting immense infrared radiation. The James Webb Space Telescope has now provided the most detailed view of this galactic merger, capturing faint tidal tails, elongated streams of material stretching from the outskirts of the galaxies due to intense gravitational interactions. These features give astronomers valuable insight into the dynamics of galactic mergers. The red and orange filaments captured in JWST images reveal scattered interstellar material further, emphasizing the dramatic consequences of these cosmic collisions. Another incredible revelation from JWST came when it identified a series of primordial galaxies at the edge of the observable universe. At first, many researchers were skeptical, suspecting that these could be nearby galaxies disguised as ancient structures. However, after sharing their findings with other scientists worldwide, their existence was confirmed beyond doubt. Thanks to JWST advanced imaging capabilities, we can now observe the oldest galaxies ever seen, shedding light on the rapid emergence of early galaxies. Astronomers estimate that the light from these galaxies has traveled for more than 13.5 billion years, giving us an unprecedented glimpse into the infancy of the universe. This finding is crucial because it confirms one of JWST's most important objectives: studying the earliest epochs of cosmic history through infrared observations. The telescope's ability to measure extreme redshifts is what sets it apart, allowing scientists to peer into the distant past and analyze the first galaxies that formed. These revelations have caused a significant stir within the scientific community. The early formation of galaxies contradicts existing cosmological models, particularly the Big Bang Theory. NASA's data collected from JWST spectrometers and near-infrared camera shows that 4 of the 6 primordial galaxies observed exhibit extreme redshifts, meaning they existed between 300 million and 500 million years after the Big Bang. Surprisingly, they appear to lack heavy elements such as carbon, further challenging our understanding of cosmic evolution. Given that the universe is estimated to be 13.8 billion years old, the presence of such massive galaxies so early in its history is troubling for current astrophysical models. This discovery raises fundamental questions. How did these galaxies form so quickly? How could they have become so large in such a short span of time? These uncertainties have led some physicists to reevaluate the validity of the Big Bang Theory, as certain aspects such as the inflationary model now appear inconsistent with observed data. Theoretical physicist Mayo Kaku has weighed in on these findings, stating that JWST discoveries have thrown our understanding of the early universe into serious doubt. Traditionally, scientists believe the primordial galaxies were less developed and smaller than the Milky Way, but the new findings suggest otherwise. The fact that JWST has identified 6 galaxies that existed just 500 million years after the Big Bang and are up to 10 times larger than the Milky Way raises significant concerns about whether our models for cosmic evolution are correct. Kaku emphasized that forming a Milky Way-sized galaxy takes billions of years, making it highly unusual to find such large galaxies in such an early cosmic era. These findings could force scientists to rewrite textbooks on the origins of the universe, potentially revising the entire cosmological timeline. If galaxies this massive existed so early, it may indicate that either the universe is older than we think, or that our understanding of galactic formation needs a major overhaul. Adding another twist to the ongoing debate, NASA recently tweeted about a newly discovered galaxy cluster that formed just 650 million years after the Big Bang. This fledgling galaxy cluster, still in its infancy, is expected to grow into a mass system similar to the colossal Coma cluster. The region where this is happening is unique, acting as a hotspot for rapid galactic evolution. Thanks to JWST, researchers can now measure the velocities of 7 galaxies within this cluster, confirming that they are gravitationally bound together, forming a protocluster. To put This in perspective. NASA scientists compared these distant galaxies to small droplets of water in different streams that will eventually merge into a powerful river. This analogy perfectly illustrates the cosmic process of galactic clustering and growth over billions of years. As new data from JWST continues to emerge, it is becoming increasingly clear that the Big Bang model may not fully explain the complexity of the universe's formation. The telescope's findings are pushing astronomers to rethink long-held theories, and the debate is far from over. More observations will be needed to determine whether these discoveries disprove the Big Bang theory altogether, or simply require modifications to our current models. One thing is certain: the James Webb Space Telescope is revolutionizing our understanding of the universe. Its discoveries are reshaping astronomy, offering glimpses into cosmic phenomena that were once beyond our reach. The more we explore, the more we realize how much we still don't know about the cosmos. As we continue to peer deeper into space, new discoveries may completely rewrite the story of the universe's origins. The discoveries made by the James Webb Space Telescope (JWST) are not just reshaping our understanding of the cosmos, but also challenging some of the most fundamental theories in astrophysics. The detection of a supermassive black hole moving at 4 million mph, the formation of new stars in its wake, and the unexpectedly large primordial galaxies have forced astronomers to reconsider long-standing beliefs about how the universe evolved. One of the most perplexing aspects of JWST findings is the unusual behavior of the black hole that appears to be leaving a trail of newborn stars instead of devouring everything in its path. This phenomenon suggests that under specific conditions, black holes might trigger star formation rather than inhibit it. Scientists believe that when the black hole moves through intergalactic gas, it compresses the material, cooling it down enough to collapse and form new stars. This theory, if confirmed, could significantly alter how we perceive the role of black holes in galactic evolution. Meanwhile, the discovery of galaxies that existed just a few 100 million years after the Big Bang but are already as massive as the Milky Way has left astrophysicists in shock. Traditional models suggests that galaxies grow slowly over billions of years through gradual accumulation of gas and mergers with smaller galaxies. However, these ancient galaxies appear too large and too well formed to fit this model, leading scientists to question whether our understanding of cosmic evolution is incomplete. Some researchers are even exploring alternative cosmological theories